Today we're going to continue with section 9.9. And today what we're going to do is we're going to evaluate the three trig functions by setting up ratios and then finding the missing sides and angles of the right triangle. So in the past, we've always given you a triangle and we've just asked for one particular thing for you to find, whether it be a side or an angle. But here, sometimes I'm going to give you a triangle and I'm going to ask for you to find all the missing pieces of the given triangle. Okay, notice in this directions, I'm asking for us to round sides to the nearest tenth, so 1 decimal, and angles to the nearest degree. So we do still want to think about our special trig word, which is SOHCAHTOA. And when we are asked to find all the missing pieces of the triangle, well, there's 3 sides of a triangle and 3 angles. And given what we know, we should start off with 3 pieces given to us, and it's really then just 3 things that we're trying to find. So here we're given triangle ABC. Well, notice that I am giving you one of the sides. Notice A and B are sides we want to find. The reason why 15 is what we would call C for side C is because it's across from angle C. So that's how it works. Notice how angle A, well, what's the side across from it? Well, it's side A. So that's kind of how that works. Okay. Notice that we are given a 34-degree angle. Well, that's for angle B. So that's 34 degrees. Angle C is marked as a right angle, so that's 90 degrees. So once again, notice I'm giving you 3 pieces, and then we're trying to find the other 3. So we're trying to find 2 sides and an angle. So let's start with what we know. Since I know 2 out of the 3 angles of this triangle, that's probably the fastest one to find. If you remember, 3 angles of a triangle add up to 180. Because one of the angles is 90 degrees, that means that the 2 remaining angles have to add to 90. So essentially, angle A and angle B are what we call complementary. So to find the measure of angle B, we can very quickly calculate this by just subtracting 34 from 90 degrees. So 90 minus 34 is going to give us a measure of a 56-degree angle. So now that I have that, I just need to find the 2 sides, and that's where trigonometry comes in. I'm going to stick with the angle of 34 because that's what's given, and now I'm going to mark all the sides of my triangle based off of that angle. So notice that side B is across, so that would be the opposite side. A is the side that's right next to it, that's the adjacent side. 15 is across from the right angle, so that's why that's the hypotenuse. But once again, I labeled those based off of the 34-degree angle. So that's the angle we want to use when we're setting up our trig ratios. So let's just find the side of A first. We have to use the hypotenuse because that's the only number that's given to us. Adjacent is what we're trying to find. So adjacent and hypotenuse, if I'm thinking about SOHCAHTOA, would be the cosine. So we want the cosine of 34 degrees to equal A, because that's adjacent, over 15, because that's the hypotenuse. So I want to get the A by itself. I want to get rid of that division. So I'm going to multiply both sides by 15. And then luckily for us, that gets us the variable by itself. So then we can just type into our calculator 15 times the cosine of 34. Once again, because the directions are asking us to round to the nearest tenth, we want to move it to 1 decimal place. So that means you have to look at the second decimal. So I see 12.43. So the 3 tells me that the 4 is going to stay as it is. So we get 12.4. Another thing to notice is that my leg that we just found, A, has to be smaller than the hypotenuse, which it is. So that checks out as well. Now, even though I have technically 2 sides of my right triangle, I'm not going to do Pythagorean Theorem to find the 3rd side. The reason why is because we rounded our answer for the side of A, and so then if we use a rounded number, it's going to be not an exact answer when we try to find side B. So we're going to go back to doing our SOHCAHTOA again. This time, if I want to find B, notice that it's opposite the angle, and we still want to use the hypotenuse. So opposite Opposite and hypotenuse means that this time we want to use the sine. So sine of 34 degrees is going to be b, because that's opposite, over 15, which is the hypotenuse. Once again, in order to then get that variable by itself, I want to get rid of division. So I'm going to multiply both sides by the denominator. So I get to multiply both sides by 15. It happens to get me my variable by itself right away. Once again, we're going to round to the nearest tenth. In the calculator, hopefully you're seeing 8.38. So that second decimal is going to round that first decimal up. So we should get then 8.4. Once again, notice how that side is still smaller than the hypotenuse, so that checks out. There are all my missing pieces of the given triangle. So let's try another one. Now, if I give you this triangle ABC, let's figure out what we already know, and then we can find the missing pieces. So notice that I'm giving us one side of 8. Notice that that's across from angle A. So that's going to represent side A. So that's 8. 15 is also given to us. That's across from angle C. So that's side C. So this time I'm giving us 2 sides. Notice that the only angle I'm giving us is that 90 degrees for angle C. Now, if you look at 8 and 15, I don't want you to think, oh, 17, because it's a triple. It would be a triple, but the 15 would have to be a leg. And right now, it's the hypotenuse, because remember, it's across from the right angle. So in order to find my missing side, we're going to have to do Pythagorean Theorem. So let's start there. Remember, Pythagorean Theorem is a squared plus b squared equals c squared. So let's plug in what we know. A is 8, b is what we're trying to find, c is 15. So 8 squared is 64, 15 squared is 225. I'm going to subtract 64 from 225. That gives me 161. To get rid of a square, we're going to take the square root. Normally, when you take the square root, you get 2 answers, but because we're finding the length of the side of a triangle, we want to keep it positive. I want to put it in my calculator. If your calculator just spits back out the square root of 121, notice how right above the enter, if you have this calculator, you might see this kind of button. So then type that button and it will turn it into a decimal for us. So once again, I look at the second decimal. So I see 12.68. So that 8 tells me that I want to round the 6 up. So it's 12.7. Notice how that number is still smaller than the hypotenuse. So that checks out. That is going to be my side. So now the only thing that's missing are the angles. And it honestly does not matter which one of those 2 angles you decide to find first. I think I'm going to find angle A. So if I want to find angle A, I'm going to use the 2 numbers that were given to us, which are the 8 and the 15. We already know the 15 is the hypotenuse, but what is 8 in relationship to angle A? Well, notice it's directly across, so it is the opposite. So when I'm thinking about SOHCAHTOA, I want to think about what's opposite and the hypotenuse. Well, that means we want to use sine. So we would set it up as the sine of angle A, because that's what we're trying to find. And that's going to equal 8, which is opposite, over 15, which is the hypotenuse. So in our calculator, remember, we want to use the inverse button when we are calculating our angles. And we'll do 8 divided by 15. Like the directions say, we want to round to the nearest degree. So in your calculator, you should be seeing 32.2. So to the nearest degree would be 32 degrees. Once you found one of the acute angles, you actually do not have to do trig to find the other one. Once again, remember, the relationship between the 2 acute angles is that they have to add up to 90. So we are actually able to find angle B very quickly by just subtracting 32 from 90. 32 taken away from 90 is going to give us that other missing piece. Angle B is 58 degrees. So that's us evaluating 3 trig functions by setting up ratios, and that allows us to find the missing sides and angles of the right triangle.